Hi folks, welcome back to Physics with Captain Rod. The purpose of this video here is to help you out with number 5 in unit number 2 here, and it says, let's see, a jet aircraft with a mass of 4,600 some kilograms has an engine that can exert a force around 60,000 newtons. Part A, what is the jet's acceleration? Part B, what is the jet's speed after it accelerates for 9 seconds? Part C, how far does it go after 9 seconds? Alright, so I've already kind of started my picture. Now, of course, this is a prop plane and not a jet, but it's the closest thing I had without doing too much looking. And you'll notice what I'm trying to do is draw a motion diagram to help indicate that this thing is getting faster and faster and faster. In my first picture here at t equals 0, the plane's not really moving yet, no velocity. In this picture, the plane's moving a little bit, so I might give it a wee little bit of a velocity vector. Now the plane's moving a bit faster, so its velocity has increased. Now it's moving even faster, so its velocity has increased. The acceleration of the plane is in this direction. I'm going to assume constant acceleration for this problem. So right now I'm just drawing a picture that's kind of describing what's going on. Now for part A here, let's see, what is the jet's acceleration on takeoff? Well, questions about velocity, time, acceleration, position, right? Those are motion questions, and hopefully you've seen my previous videos on how to analyze motion. I would start with a velocity graph here to describe the motion of the jet. Now I'm not going to work it for you, but I'll tell you things to consider. So you're going to do velocity against time, and you know, I always recommend when people are struggling with their graphs to start with intercepts or start with the things you know. At t equals 0, the plane is not moving yet. Right, so put that first point on the graph, but I'm not going to tell you where, or maybe a little hint, probably pretty close to about there. Sometime later, in fact, does it say in the problem? No, we don't. We don't know the time. And we don't know the v final. So really about all we can do here is say, well, maybe t and v, and I'll just put that point on the graph. Right? Then connect the dots, assuming constant acceleration. Now, the acceleration we may have gotten from the slope, but we don't know the t or the v, so it doesn't mean this is wrong, but I think what I'll do here is kind of move on and read this thing again. Oh, we do know the mass and a force, so we can get the acceleration from Newton's second law. So write out Newton's second law, F equals ma. Take the given force and the given mass to find the acceleration. Once we find the acceleration, now when we come over to our graph here, we're going to know the slope of this line, and that's going to allow us to write out a couple of equations here. Let's see. For part B, it says, what is the speed after 9 seconds? So I'm just going to change this, well, I'll just leave that to a 9 seconds. And using slope, you should be able to write an equation out that's going to give you the velocity at that point. Remember, rise over run. There's your slope. And that is going to be the velocity at 9 seconds. And then part C, where it says how far during those 9 seconds. Well, the area bound under the curve will give you the how far. So I think that's pretty well enough on this problem. I've just about got the whole thing completed for you. I hope this helps you with your homework. Have a great day.